Let us analyze a pure capacitive circuit. A capacitor is connected across the supply voltage V, which is given by Vm sin omega t. Now we have to find the current equation or current through the capacitor. So first we will write the capacitor voltage, which is equal to the applied voltage. So V equal to 1 by C integral of I dt. So from this let us find what is I. So differentiate this one. So you will get I is equal to C into dV by dt. So C into what is V? Vm sin omega t. So differentiation of sin omega t with respect to dt. So here you have only dt, not d omega t. So differentiation of sin omega t is omega into cos omega t. So omega c and Vm cos omega t. So V equation is here, I equation is here. So let us convert this cos omega t into sin omega t form so that I can compare these two easily. So I is equal to omega c Vm sin omega t plus 90 degree. Let us find the impedance of the circuit. V is given by Vm sin omega t and I is omega c Vm sin omega t plus 90 degree. So what is impedance Z? That is equal to Vm divided by Im, that is equal to 1 by omega c. This omega c, 1 by omega c is given by Xc, which is called capacitive reactance. So instead of omega, I can write 2 pi f. Let us draw the phasor diagram. Voltage and current are given. You see, voltage waveform starts at 0 because sin omega t, there is no angle, so it starts at 0. Whereas this one, current waveform is omega t plus 90 degree. It means that it is starting ahead. That is before 90 degree itself it starts. So the current waveform has started here, whereas the voltage is lagging, or I can say the current is leading the voltage by 90 degree. So if this is voltage, current waveform will be here, that is it is ahead by 90 degree. Let us calculate the instantaneous power. Multiply voltage and current, you will get the instantaneous power, and we have this waveform. So here both are positive, you will get positive part. One is positive and the other is negative, so negative part. Here both are negative, minus into minus will give you positive. So you can see here this part, positive part and negative part are equal. So the average value is going to be 0. The formula for average power is given by P is equal to 1 by pi integral of 0 to pi Vm Im sin theta cos theta into d theta. Let us simplify this one. Sin theta cos theta can be written as sin 2 theta divided by 2. Simplify it, integrate it, apply the limits. You will get 0. So in a pure capacitive circuit, the real power consumption is actually 0. This is similar to a pure inductive circuit where the average power is also equal to 0. Then we will find the power factor, which is given by the cosine of the angle between voltage and current. So here angle is 90 degree. So cos 90 is 0. And in this case we call it as 0 leading because the current is leading the voltage. So we call it as a leading. So the points to remember here are, for a pure capacitive circuit, voltage and current equation are this one, and the current leads the voltage by 90 degree. Power factor is 0 leading and the average power is 0, and the impedance is called the capacitive reactance and X is equal to 1 by omega C. If you like the video, subscribe to Read Electric Vehicle channel. Thank you.